Hello everyone, and thank you very much for the honor of being able to share some thoughts with you today. The provocative title that I've chosen is Cars, Cats, Climate Change, and Other Neglected Problems of Animal Welfare. Does everyone know the story of the Little Prince? And do you remember the episode where the little prince discovers that he's very attached to his own special rose, even after he realizes that it looks very like the hundreds of wild roses that he's just encountered on Earth? And while he's pondering this mystery, a fox approaches him. Here's the picture. And the fox asks to be tamed. The fox explains that the reason why the little prince is so attached to his rose is that it's his rose, and the fox wants to become his fox so that he'll receive the same kind of care. And the fox concludes, "You become responsible forever for what you have tamed." The ethic captured in The Little Prince reflects a time when there was still a fairly clear division between tame roses and wild roses, between tame foxes and wild foxes. My argument today is that with a busy population of 7 billion people and counting, we have such pervasive effects on all the other inhabitants of our own small planet that our responsibilities have broadened greatly, and that we need today a new ethic that will combine what we now call animal welfare and what we now call conservation into a coherent approach. But since that sounds a bit abstract, let's start with a story and a quiz question. In 1957, a new television transmission tower, 300 meters tall, about the height of a 100-story building, was put up in a small community in Wisconsin. And late one evening, toward the end of August of that year, a local resident reported that it was raining birds. And in the morning, several hundred dead birds were collected from her roof and garden and the neighboring properties. The local people were mystified and a little frightened. A biologist said he thought it was caused by poisoning. The local health officer asked that the birds be collected and buried, apparently fearing a disease. And the local television parts distributor, in a pronouncement that must have been especially reassuring to the residents, insisted that they had been killed by a lethal electrical discharge coming from the tower. Fortunately, the event attracted the attention of Dr. Charles Kemper. Here he is, a local doctor and a diligent wildlife rehabilitator. And in an astonishing display of dedication, Kemper and a helper visited the tower almost every morning for the next 38 years. So here's my quiz question. How many birds do you think they collected in the 38 years from the one tower? And I'll just keep the numbers increasing, and I'll listen carefully, and you tell me when to stop when you think I've reached the right number. I'm listening. There's the answer. 121,560 birds. Kemper was actually the first of many dedicated people, often interested amateurs, who monitored towers in various parts of North America. And recently, Travis Longcore from California led a group in an analysis of all the available data, and they concluded that communication towers must kill about 6.8 million birds per year in the United States and Canada. Now, it's hard to wrap your mind around a figure like 6.8 million birds, so Longcore expressed it a different way. In 1989, the supertanker Exxon Valdez ran aground in the Arctic, spilling an amount of oil that held the world record for the next 20 years. It killed an estimated 250,000 birds, together with a much smaller number of marine mammals and an unknown number of fish. It was universally regarded as an animal welfare and ecological disaster. Longcore noted that in terms of the number of birds killed, the communication towers represent roughly an Exxon Valdez running aground every 2 weeks. In the 1970s, I was doing research on this animal, moose, in central Canada, and I found that during the months of May to July, the moose were strongly attracted to naturally occurring sources of sodium salt, such as this area, which is actually a small sodium-rich spring attracting so much moose activity that it had become this barnyard-like scene deep in the forest. I also realized that the months when moose were attracted to the mineral springs were the same months, May to July, that saw most of the year's vehicle collisions involving moose. And it occurred to me that they might be attracted to highways because of residues of highway de-icing salt. So I set up a field camp in an area where moose collisions were particularly common, and I found that most of the collisions were happening near areas like this, which were low-lying, wet areas that weren't being flushed with snowmelt and rainwater and were therefore accumulating high concentrations of salt in the water. And once we understood the problem, there were some obvious solutions, in this case, just improving the drainage so that the salt would flush away with the rain. Now, to most conservationists, road accidents seemed a pretty minor problem. But recently, Richard Foreman and a colleague, 2 landscape ecologists, did a study of the ecological effects of roads, and they concluded that cars and roads must kill roughly 1 million vertebrates per day in North America, and that sometime in the late 1900s, roads and vehicles, quite apart from their role in disturbing habitat, had surpassed hunting as, in their words, the leading direct human cause of vertebrate mortality on land. 1 million a day would be an Exxon Valdez every 6 hours. And one more example. Can you make out this poster? This is from a Toronto-based group that's trying to reduce the collisions of birds with windows. And in addition to taking a huge number of injured birds for rehabilitation, they tried to drive home the carnage they were seeing by creating this poster, which shows a small sample of the dead birds collected from an area of office buildings. Window strikes haven't attracted much attention from scientists, but one exception is the American ornithologist Daniel Clem, who has been studying window collisions for more than 30 years. And after amassing a huge amount of evidence, Clem concluded windows and other reflective and transparent surfaces likely kill 1 billion birds each year in the United States and billions worldwide. If his estimate is roughly correct, then windows and similar surfaces would be the equivalent of an Exxon Valdez perhaps every hour. And Clem's data indicate that for every bird killed, there's one that's injured in a way that does not cause immediate death, and of course a small fraction of these birds will end up in wildlife rehabilitation. All right, those 3 cases, communication towers, vehicle collisions, and windows, are 3 examples of direct but unintended harms to animals caused by human actions. And there are many others, including fisheries bycatch, ghost fishing by lost nets, pesticide drift, oil spills, both accidental and the deliberate dumping of used ship engine oil at sea that is thought to kill roughly the equivalent of an Exxon Valdez every year off the coast of Newfoundland, and cropping operations such as plowing and mowing fields, which may have the greatest effect of all simply because they're done on so much of the Earth's surface. Now, in these examples, I've used the number of deaths as a metric of the amount of harm, but this is not because death is the only harm or the most important harm. Instead, we're likely to see a spectrum of harms, including suffering, injury, and deprivation of individuals, and in some cases, decline of populations, disruption of ecological systems, and occasionally extinction of species. Now, the first 3 of these, suffering, injury, and deprivation, would often be called problems of animal welfare. And the last 3, declines of populations, disruption of ecological systems, and extinction of species would be called problems of conservation. But of course, all these types of harm can arise from the same human actions. All right, those were unintended but fairly direct ways in which we harm animals. Let's now think about indirect harms to animals. By indirect, I mean that there is some intervening process and usually a time lag between the initial human action and its effect on animals. An example might be releasing methane into the air, because the type of methane, the levels of methane we release, they're not directly toxic to animals, but they're thought to contribute to global warming, which will affect animals in the future. The distinction isn't always watertight, but it's fairly useful for a reason that I'll come to. Of course, the classic indirect harm to animals is habitat alteration, shown here. In North America, the range of our large predators, grizzly bear, gray wolf, black bear, wolverine, and cougar, has been reduced by roughly 40% from the original values, and of course the reduction is far more severe in the southern semi-agricultural areas. The loss of these top predators will have huge effects on other animals, the best known being the occasional explosion of herbivores that can then destroy their habitat. But to illustrate more subtle effects, let's think about mesopredator release. This occurs if a top predator such as the wolf is important in controlling the number of mid-sized predators such as raccoons, skunks, foxes, and feral cats. If a habitat fragment is too small to support a top predator, then mid-sized predators may become superabundant, and small prey may find themselves under extreme pressure. Biologist Paul Paquette refers to such pockets of habitat as wilderness ghettos, where a species may persist but under abnormally difficult conditions. Deforestation is a physical change. Let's now think about a chemical change. Here is Lake Erie, one of the 5 Great Lakes located on the border of Canada and the United States. It's the world's 10th largest surface of fresh water, and until 1950, it was a rich and complex ecological system. My first exposure to Lake Erie actually happened in the 1950s, when a neighbor invited my brother and myself to spend an afternoon at their cottage on the lakeshore. We, of course, packed up our swimming gear, but when we arrived, what we found was not so much a lake as a solid mass of green algae. Well, we were farm boys and not deterred by a little excess vegetation, so we thought we would rake out a clearing. But after half an hour of raking rafts of smelly algae and dead fish onto the shore, we decided to go inside and play cards. Well, this was the early days of the Green Revolution, and it sure was green. Essentially, the new chemical fertilizers combined with municipal sewage had increased the nutrient load in the lake to the point that the algae had grown, and then when the algae died and decomposed, that used up the oxygen and killed off the animal life. Over the next decades, a lot of progress was made in cleaning up the algae, but here is a recent aerial photograph, satellite photograph, showing that the rafts of green algae are once again becoming very common in the lake. Now, we're accustomed to seeing a farm pond choked with algae, but it came as a total surprise to see this happening in a water body the size of Lake Erie. And yet, as we can see in this section of ocean shore, something similar is now happening in areas of ocean. A recent review of coastal dead zones, that is, areas of ocean where nutrient loading leads to a lack of oxygen, concluded dead zones have now been reported from more than 400 systems, affecting a total area of more than 245,000 square kilometers, that's about 10 Lake Eries, and causing mass mortality and changes in community structure. As a final example, let's take the introduction of invasive species as an example of harm caused by human actions. New Zealand is a kind of world capital of this problem. and has provided some really interesting research. Fantails are a native bird of New Zealand, and in a study in Dunedin, biologists collected records on the number of fantails and other native birds killed by a sample of 150 cats. Then they extrapolated those kill rates to the estimated cat population of the city. And for fantails and a few other species, the total number killed each year was roughly equal to the estimated total number living in the city. The report concluded, "We suggest that urban populations of birds in Dunedin may be population sinks," which is a technical way of saying that fantails and some other species probably only exist in the city because new targets keep moving in from the surrounding area. And just to show that cats are not unique to New Zealand, a recent analysis of cat predation in the United States concluded free-ranging domestic cats kill 1.4 to 3.7 billion birds and 7 to 21 billion mammals annually. All right, there are 3 examples of harming animals indirectly by disturbing the processes and balances of nature: habitat alteration, pollution, and introduction of invasive species. And again, we could add lots more, such as the spread of animal diseases, acid rain, and of course, climate change. The harms caused to animals in these ways are so diffuse that it would be nonsense to try to say how many individuals are affected, but data on species extinctions may provide a metric of the seriousness of the effects. For example, John Mackenzie, in his book Birds in Peril, calculated that of the 76 full species of American birds that had become extinct since 1600, 13 had succumbed to the direct harm of hunting, whereas 63 species disappeared because of indirect harm, 14 because of habitat destruction, and 49 because of introduced species. And in an effort to predict the effects of climate change, scientist Chris Thomas and a large team applied climate change models to a wide range of animal species and regions in the world, and they wrote, "We predict, on the basis of mid-range climate warming scenarios for 2050, that 15 to 37% of species in our sample of regions and taxa will be committed to extinction. And if that prediction is accurate, then climate change would dwarf all other human activities as a cause of extinction." Now again, in these examples, I've used extinction of species just as a metric to help us appreciate the magnitude of the harm, not because it's the only harm involved. In fact, it's hard to imagine driving species to extinction without causing probably all the other types of harm: suffering, injury, deprivation, death, and so on. To quote Paul Paquette again, "The same human activities driving the current extinction crisis are also causing suffering, fear, physical injury, psychological trauma, and disease in wild animals." Now, a lot has been made by scientists and philosophers about the distinction between animal welfare and conservation, where conservation generally focuses on wild animals, looks at populations, ecological systems, and species, and addresses concerns about biodiversity, extinction, and ecological integrity, whereas animal welfare on the right tends to focus on captive animals, often domestic ones, looks at individuals, and tries to address problems of animal health, their quality of life, and their emotional states. But of course, our communication towers and windows, our pollution and greenhouse gases, are causing this wide spectrum of harms that include both animal welfare and conservation. What we need then is a set of actions and policies that include the full spectrum of harms that we have on animals. So what can be done? Well, actually, in the case of the direct but unintended harms, there's often a lot that can be done to mitigate the problems. For example, in the case of towers in North America, much of the damage is caused to passerine birds migrating at night, and the kill rate is closely related to the height of the tower and the lighting. So research indicates that the kill rate could be greatly reduced if we can avoid extremely tall towers and use flashing lights instead of steady burning lights. There's also some new research suggesting that use of blue-green light rather than the usual red or white light might almost eliminate the kills. Windows kill birds in several different ways, so the solutions need to be specific to the situation. For nighttime collisions with tall buildings, just turning off the lights at night can reduce the kills. For daytime window strikes, windows composed of panes are much less a problem than large sheets of glass, so it's beneficial to subdivide the surface using films or other material. We also need to manage vegetation, for example, by not having potted trees behind windows. And the placement of bird feeders is important, especially keeping bird feeders close to the windows so birds don't gain enough speed to have a serious collision. Cats also need to be managed according to specifics. The data from New Zealand show that many cats don't hunt if they're well fed, and that most predation is done by a small percentage of cats. So, observing the cat is the first step. Those that do hunt can be made safer by attaching bells or cat bibs and by managing their outdoor time. But when it comes to indirect harms caused by habitat change, pollution, climate change, and so on, where the eventual harm to animals is likely to be widespread and in the future, there is often little we can do after the environmental change has happened. So the only solution is to protect the life-sustaining processes and balances of nature in the first place. By, for example, minimizing habitat loss and pollution, not introducing novel species, and so on. And here animal ethics becomes really radical, calling for us not just to avoid intentional harms, such as hunting and slaughter, but to live lives that cause a smaller ecological footprint. And here, animal welfare concerns and conservation concerns are closely aligned. Given that human activities cause so much harm, and that in many cases something can be done to mitigate the harms, what's the missing ingredient? I think it's something close to the Buddhist virtue of mindfulness, in the sense of paying attention to the result of our actions, and linked to that awareness, taking steps to avoid causing harm. Mindfulness could lead us to make changes in our personal choice decisions, how much and how fast we drive in areas of wildlife habitat, how we manage our cats, how we place our bird feeders, and so on. Mindfulness could also lead us to take collective actions. Every glass office tower is the workplace of people who together might be able to reduce the effect of the building on window strike for birds. Every customer of cell phones and high-definition television is the customer of a company that might be persuaded to improve the safety of its towers. And mindfulness might even lead to changes in social policy, in setting design standards for buildings, in locating roads and suburbs, setting speed limits in wildlife habitat, and so on. So, like the Little Prince, we, with our 7 billion busy people, also live on a small planet, where the roses and foxes are not necessarily tame, but so profoundly influenced by our human actions that our responsibilities are far greater than we had imagined even just a generation ago. Thank you very much.